Great, thank you very much. Good morning, everyone. Yes, so this is, I guess, the first paper from a very large project that is being undertaken at Northwestern University in collaboration with the University of Oxford, and it's about data collection for self-reported social networks. And so here we have Bob, and we want to know a couple things about Bob. Now, we might want to know, for example, how many friends does Bob have? And that's kind of can be a bit of a straightforward question. Maybe we'd go to Facebook or something else. But, you know, how many of these friends know each other? How many of these friends have had sex with Bob? Whoa, well, that really escalated quickly. And how many have done drugs with Bob? Well, these are actually relevant questions. And what's relevant about them is that they're actually very hard to get from trace data. People do not normally post who they have sex with, who they do drugs with, but yet for epidemiological purposes and for purposes of public health, it's really important to find accurate representations of these, both at the scale of an individual and also at more larger, more macro scales. So we can think that Bob knows a number of people and they're in his head, and then we want to know if these people know each other. So normally you would then ask them one after the other, and this is what's called a dyadic census. So does Alice know Bob? Does Alice know Charlie? Et cetera, et cetera, et cetera. And then you go through this sort of matrix of dyadic questions, and people really do lose their mind on this. They really do not like this. Because the problem is that it scales exponentially with the number of alters. You ask about 6 people, it's not a problem. But normally these networks end up in this sort of midpoint here between 12 and 25, which ends up being anywhere between 60 to 300 questions per person per interview. Now, we ask not just about one type of relation, but 3 different types of relations: social ties, drug ties, and sex ties, so you multiply it by 3, and it's really complicated. So we want to be able to find ways to simplify this task. Now, about a decade ago, I was part of a group that had done a paper version of this. This wasn't a prototype. We really use this in the field, just with Post-it notes on a piece of cardboard, and then you lay them. People write their names, and they lay them on a giant concentric ring circle. This helps. The circle itself helps people organize the layout of the ties and helps to stabilize their sense of where people are in relation to each other. So you ask them for different kinds of ties, and then you ask them to draw the edges of who knows who and who's friends with who, et cetera. And so this is an example of one of those in the field. I'm not the only person to be using these now. This is by Dubois and Ford. The edge of this, it's cut off there. I see. Dubois and Ford. It was been used at Google to help design their social circles in its own way, and used in public health and epidemiological studies. And, you know, thus far it's actually found some successes in some arenas. Now, the pros about this sort of technique are that it's enjoyable, and we have found in past that it's as accurate as matrix-based methods or dyadic censuses. It has fast delivery. You can really deploy this much more quickly than where you ask, does Bob know Charlie, et cetera, et cetera. But it's really slow to code. We have to get this data into a computer somehow, and it's really tedious. Sometimes you'd be there with like a magnifying glass to try to determine, does this person know this one? And ink is typically permanent. If people draw this map, then they have to move it around, and they have to draw another map. You can't really tweak much with this. So this seems like the sort of thing that would be really ripe for digitization, and it's been tried. So we have, for example, anemia, but unfortunately it's very bespoke. It's very hard to customize. And it's in Flash. Sorry, Apple, or Adobe guys, sorry. And then we have, for example, VenMaker, but VenMaker, it's made with NetBeans, and it seems like it's just sort of sticking together and projecting a lot of the data model right onto the user interface. And it looks very busy, and you really cannot do this in any way that's been self-administered or even close to it. So this leads me to a couple research questions. The first one: can these software programs accurately capture the appropriate data? Can we get them to get, based on what we know and how we know how to collect this data, can we get software to work? And the second is, how can they be built to accommodate more flexible and responsive designs? How can we make this more simple, more easy to use? And so we've been working on a program called netCanvas. And some of the concept of netCanvas is that we have nodes as first-class objects, and they're exposed through views. through a number of canvases. We try to ensure that every canvas itself is a single task, a single action, or a single form of data collection. We try to really not overload the screen and to have it nice, easily understood, very large buttons, very easy to manipulate. And so here are some of the screens that we have in netCanvas for various purposes. Up in the top there is how we generate names, and then we have screens for dropping down by gender, screens for roles, screens for calendars, maps, network maps, different kinds of network maps, and so forth. So under the hood, I mean, this is all. This is the reason that this worked, I guess, in many ways, is because of the open standards that we were able to draw upon. We're using HTML5, CSS3, a lot of JavaScript in there. The back end is all Node.js, so we've been using this as an application. We built it as a single standalone application because it has to be, in our particular tests, used in a very secure environment. We use Neo4j for our data model, which is kind of different than a lot of network studies, but it's actually been really, really worth it for us in the end. And Leaflet has been great for helping us get our maps in there. Oh, wait, I'm sorry. It's been coded by someone from England, so in fact we should say it's under the bonnet. Apologies for that. So the research context with this is that we're interested in collecting data about young men who have sex with men. Under 25s in the US, about 8% have had some sort of same-sex relation, and about 3 to 4% identify as gay. But yet, among the under 25s, 67% of all new HIV cases in 2008 were for young men who have sex with men, and that's risen to 80% in 2013. So in researching this, my colleagues at Northwestern have started a program called Crew 450, which was a data analysis or data collection effort. And then there was a sub-collection of that called Link. Now, in Link, 175 participants drew their social network, and they did it using magnetic poetry type things and markers on a whiteboard. And then they came up with this sort of macro network where you're able to unify names across different researchers and get a sense of the spread of HIV. Now, that was a few years ago, and since then they've expanded Link to a different study called Radar. Radar is a sort of a larger, enhanced version of Link, where we're doing a 5-wave longitudinal cohort study of up to 1,200 men who have sex with men in downtown Chicago. And we're looking at the incidence of drugs and sex. Particularly, the term is condomless anal sex. It's a very well-known vector of HIV, and it's really important to capture this as accurately as possible. Now, if you recall from the last screen, they were doing this on markers and magnetic poetry. It's not great. It was slow to code. There were errors in data collection. There's just a lot of user needs here for digitizing this. So that's where we applied netCanvas. We did this at this lovely place called the Center on Halsted, and this is a sexual health and resource center in Boys Town in Chicago. In there, we have a series of interviewers who would ask individuals if they want to participate. Of course, we go through all sorts of IRB and ethical review. In fact, it's to the point where we have what's referred to as a certificate of confidentiality. So our data cannot even be subpoenaed by the Supreme Court. This data is highly secure, and we let our participants know that and try as hard as possible to ensure that that data stays that way. Now, you might remember that I said that we had that this Radar study had been an outgrowth of a particular study called Link, where they did with markers. It turns out a number of the Link participants were also recruited into Radar. And so this became a sort of natural experiment. Having done both the pen and paper, or the marker version, and the digital version, we can compare the results on the two of these and check for consistency. In addition, Radar also didn't just use netCanvas, this nice touchscreen thing, but a very boring and long interview. Well, it's not. Some people wouldn't say it's boring, but they designed it. A very long interview called HRASP, which is very tediously going through person by person. Does Alice know Bob? Does Alice know Charlie? So this is an opportunity for us to both compare the pen and paper to the digital version, as well as compare the digital version to an interview. And that's where we can derive some hypotheses and then start asking whether or not this tool actually worked. So we have a number of hypotheses. They're pretty straightforward. The first is users who've completed both an analog-based participant-aided sociogram, markers and such, and those who have done netCanvas will report either equal or more alters on netCanvas. That netCanvas will help them disclose more people. They'll either think of more people or they'll be in a better state of mind to disclose more names. Hypothesis 2 is that users who've completed both an analog-based and a digital one will be faster on the digital platform. 3 is that there'll be no evidence of a learner effect. That is, those people who did the link version earlier, maybe they get networks, and maybe it's faster because they've already done this sort of thing before. And so, we're going to compare them to the newbies. And then finally, users will indicate high degrees of satisfaction and usability of the netCanvas platform. And that'll include expressions of like enjoyment or satisfaction with the data collection experience. Now, it's worth noting that these are not randomly controlled trials where we're able to give one a stimulus and the other some sort of placebo or whatnot. And the reason is because these are very difficult populations to access in the first place. And in fact, it was somewhat fortuitous that we're even able to have the same population compared between the analog and the digital one. But this data is too important for us to muck around with our methodology. We had to merely optimize it as effectively as possible and then hope that we could find ways to test this. So for the first hypothesis, this is link versus radar, and we're wondering whether they've disclosed equal or more alters. Well, it turns out that there's no significant difference between the two of them, so this is good. This is, it seems that the paper-based or analog-based technique and the digital-based technique in that respect are pretty much comparable. As you'll notice, within radar, in the interquartile range, as in 25% above and below the median, it's slightly larger for the drugs and slightly larger for the sex networks as well. So it's slightly larger, but it's not statistically significant using Wilcoxon rank sum test. I believe it was. It's a non-parametric test anyway. And of course, they're highly correlated between link and radar in terms of the number of people disclosed. Now, for hypothesis 1b, we're actually looking at condomless anal sex acts and anal sex acts in general. Now, it turns out HRASP did elicit more anal sex acts, not condomless ones, however. Now, that is to say, now what can be responsible for that? We have a couple explanations, and of course, neither of them are that, well, HRASP is that much better. The first explanation is that on the HRASP, they were actually just asked for a single number globally. And so a lot of people would say round up to 25 or round up to 10 or et cetera. Whereas on radar, it was much more granular. And so when you go granular, it does tend to be a bit lower. But most importantly is there was no significant difference on condomless anal sex acts, which are the key vector for HIV. So in that sense, we still are quite confident in the integrity of the data here. For hypothesis 2 and 3, is it faster using netCanvas? Well, it turns out it's about 50% faster. It's notably faster. And post-interview, it's astonishingly faster. We have a workflow now that pipes the JSON objects that come out of that directly into our Neo4j data set, and we can analyze, basically do some sort of just-in-time analysis for the next paper or conference. This difference in time remains statistically significant when we remove the link participants, when we remove the people who've already done it. And then when we compare the ones who were, the radar, the newbies, and then the radar ones who had done link, again, no statistical significant difference. However, we are finding now, we couldn't put this in the paper, but in waves 2 and 3, there is in fact a learner effect within program. So that those people who have used netCanvas and come back, we can shave about 4 minutes off of that, 5 minutes off of that research study. So that's really good. For hypothesis 4a, in terms of satisfaction, first thing we did is ask people just a single Likert scale question. Is it very easy to very hard? And then what's the first word that comes to mind? So on a rating of 1 to 5, where 1 is great, networks were rated to 1.23. The top words were fun, interesting, and easy. The calendar, not so great. And then the map, not as great still. Now, still good, but we really want to get those numbers up. We know that there are certain usability tweaks that we had to do with the maps, and they've been done post-study. But we also used the system usability scale with a different sample in order to get a much more broad and perhaps validated version of this. And there we find that the scale had a really nice high reliability and a mean score of 4.45. So, I mean, definitely something that the people were satisfied with. So here's my hypothesis roundup. What do we have? Well, can we reject the null? Yes, we can reject the null for alters. It is equal or better. The null would be that it's lower. For sex alters, the answer is mostly, and we could say yes for anal sex acts, or sorry, for condomless anal sex acts, but for anal sex acts, not entirely. It is faster. There is no learner effect. People are quite satisfied, but we can't actually say how satisfied because we don't really know what would be our expected value and whether we beat it. It seems like they were very happy with it, but we don't know what we were going to expect. And then finally, for usability, yes, we can certainly say that score is above average and beats what we expected. So in summary, social networks are highly useful for studying HIV. Capturing them is difficult, and visual methods help. Digital methods are now ready for production on account of versatility, accessibility, workflow, all these issues. And the results, they're faster, they're easier, they're more scalable, and they're fun. Finally, open web standards help us facilitate this in a responsive with tactile work. It's interactive and cross-platform. So the next steps of this, now we've got another pretty major grant in order to take the config files for netCanvas, which are now these sort of JavaScript protocol things that are complicated and no one knows how to really use them, into a more visual query builder, a visual layout builder, and make the actual act of designing a netCanvas survey as appealing as it is to do the survey itself. Finally, I want to thank the rest of my team. Josh Melville is the creator. This is my graduate student at the University of Oxford, and he's excellent. He's excellent. His work is great, and a lot of the quality control just comes from his own internal compass for what's good quality. Then we have Gregory, Patrick, Nosh, Brian, and Michelle, and they've all had a hand in this. It's been an excellent working with this team. So finally, with that, I just want to say thank you.